New observations and precise measurements have once again brought Atlas into the focus of scientific interest, not because of rumors, but due to a specific chain of data that is forcing a reevaluation of what was considered established. The latest images taken after its perihelion passage show a compact nucleus without the expected massive tail structure, while high-precision astrometry records lateral displacement and abnormal accelerations that cannot be explained by gravity alone. All of this undermines the conventional understanding of the behavior of such objects. However, behind this research narrative lies another, more troubling dimension. Sudden personnel changes have occurred within space agencies. Reports of strategic resignations are being published, and speculation is growing about possible political motives related to the withholding or deliberate release of highly detailed images. These rumors fuel suspicions that not all data has been made public for purely bureaucratic reasons. On November 4th, 2025, a statement was made that stirred the scientific community. In a social media post, President Donald Trump announced the resignation of Sean Duffy as NASA administrator and the appointment of billionaire Jared Isaacman to the position. The timing of the decision also drew attention. Some noted that the appointment followed shortly after a controversial Twitter response addressed to Kim Kardashian, sparking additional questions and rumors within the astronomical community. Is this a routine personnel decision, or are there other reasons behind it related to the observations of Atlas? While the US was in a pause due to a government shutdown, China unexpectedly released images. On October 3, 2025, the Tianwen-1 Orbiter captured the object at a distance of 28.96 million kilometers, and the images obtained by its high-resolution HiRIC camera proved to be of professional scientific quality. Although the mirror diameter of the Chinese instrument, 38.7 cm, is smaller than the 50 cm aperture channel of the American setup, the quality of the frames and the accompanying processing products caused a real resonance, including an animation of Atlas moving across the Martian sky, compiled from a series of 30-second exposures. Unexpectedly, one of the official pauses was interrupted by a US Congresswoman who posted a statement on social media. According to her, she had a conversation with NASA representatives about Atlas, and as soon as the government resumes work, the agency will release the images and data. In her message, she confirmed that the conclusions regarding tail anomalies put forward by Dr. Avi Loeb from Harvard align with NASA's observations, but due to bureaucratic constraints, the publication has been delayed. This statement is notable for several reasons. It effectively confirms that American scientists have recorded the same anomalies, it hints at the existence of other similar interstellar bodies, and it openly acknowledges the temporary withholding of key materials. An analysis of the latest observations, conducted using standard astrometric team parameters, revealed two important corrections to Atlas's trajectory. The first is an unexpected lateral displacement. The object shows significant deviations in the horizontal direction, left-right, compared to predictions, while vertical shifts are almost non-existent, indicating a very specific nature of motion. The second is a persistent non-gravitational acceleration. The acceleration signal remains, although its magnitude has been revised and is now about 1/3 of what was published immediately after perihelion. Even at this reduced value, it remains statistically significant and does not fit within the framework of conventional gravitational explanations. Technically, this means there are additional acceleration components in the orbital plane, parameters A1 and A2, while the component perpendicular to the plane, A3, is consistent with 0, meaning the forces act within the plane of motion, not pulling the object above or below the orbit. Here, physics imposes serious demands on the explanation. The conventional interpretation of non-gravitational accelerations in comets is simple. Mass ejection provides jet thrust and alters the trajectory, substituting the measured accelerations, in typical gas ejection velocities, hundreds, of ms into the momentum. Conservation equation reveals that Atlas would have had to lose a significant fraction of its mass, on the order of more than 13%, during its close perihelion passage. This would correspond to the ejection of billions of tons of material and the formation of a massive coma and tail, easily visible even with simple telescopes. Yet, the post-perihelion images show a compact nucleus and only a moderate coma. This discrepancy poses a serious problem. The reduction in the estimated acceleration magnitude eases the quantitative contradiction, but does not eliminate the fundamental inconsistency. The acceleration is present, but the cloud of ejected particles, corresponding to the classical picture, is not. Preliminary spectral measurements and comparative analysis yielded unexpected results. The spectrum is dominated by nickel with an almost complete absence of iron. The carbon monoxide to water ratio was found to be extremely high. There are signs of rare volatile compounds which, under terrestrial conditions, are associated with industrial processes. For example, derivatives of complex nickel carbonyls. For bodies born in the cold, ice-rich regions of interstellar space, this is highly atypical. Additionally, observations of light polarization revealed extremely negative values, which is interpreted as a signal of very large, porous and internally complex particles, again, not the set typically found in comets native to the solar system. Given the available data, the scientific picture narrows down to 3 plausible explanations. An atypical natural comet, extended models allowing for directed jets, particles that do not form an extensive coma or ejecta with much higher velocities. This preserves a natural origin, but makes the object exceptional. Non-thermal mechanisms, internal pulsed sources capable of ejecting mass at higher velocities than those characteristic of thermal degassing, thereby removing the requirement for mass loss on a huge scale. An artifact of artificial origin. The presence of industrial components, directed emissions, or geometrically defined structures. This hypothesis requires extraordinary evidence and is currently considered unlikely a priori, but cannot be definitively ruled out without targeted investigations. The story of Atlas has long ceased to be a routine observation of an interstellar body. Each new piece of data adds not clarity, but more questions. Today, we can identify 10 key anomalies, each of which could be considered a random exception on its own. But together they form a system of contradictions that calls into question the classical models of cometary physics. A retrograde trajectory, almost coinciding with the ecliptic plane. Atlas entered the solar system on a retrograde orbit, meaning it is moving in the direction opposite to the planet's revolution around the Sun. This in itself is already rare for interstellar objects. But even stranger is the fact that its orbital plane almost perfectly coincides with the plane of the ecliptic. The inclination angle does not exceed a few degrees. The probability of such a random alignment is infinitesimally small. For a body arriving from interstellar space, such an alignment with the planet's orbits seems, at the very least, suspicious, as if it was inserted into the system along a pre-calculated trajectory. An anti-tail, pointed directly at the Sun. A classic comet, under the influence of solar wind and radiation, forms a tail stretching away from the star. With Atlas, the opposite is true. A stable anti-tail has been recorded, a jet of dust and gas directed towards the Sun. This contradicts the fundamental physical laws of cometary behavior. Such an effect can only be explained by extremely complex interactions of particles, with magnetic fields or by the presence of directed jet. Ejections, as if someone or something was correcting the direction of the flows, and a typical combination of mass and speed. Calculations show that Atlas's nucleus is significantly larger than average for ordinary comets, while the object is moving at a high translational velocity. Such a combination of density, size, and speed is an extremely rare phenomenon. It points to material possessing strength and resilience unavailable to conventional icy and dusty structures. The question arises, if this is a natural body, what is it made of and how did it maintain its integrity under such acceleration? 4. Synchronized close approaches with planets. An analysis of its orbit revealed a whole series of coordinated close approaches with major planets. These maneuvers occurred at times when Earth-based observations were hampered by the geometry of the planets and the Sun. Such a dance-like trajectory could have reduced the number of available observation windows, as if someone was consciously minimizing the probability of directly visualizing the most critical phases of its movement. For a random interstellar trajectory, such a sequence is too sophisticated. Chemical anomaly, nickel instead of iron. Spectroscopy revealed an unexpected chemical profile, a strong predominance of nickel with an almost complete absence of iron, and an excessively high carbon monoxide to water ratio. This is not just rare, it is an anomaly incompatible with the conditions of body formation in traditional cold regions of protoplanetary disks. Such a combination is possible in high-temperature environments or in technological processes involving metal refining. Some researchers cautiously suggest that we might be looking at a product of artificial origin, or at least a material that has undergone unusual processing. Extremely negative light polarization. Optical polarization measurements showed record negative values, indicating large, highly porous particles with a complex internal structure. This is not just dust. This is material with specific optical properties, characteristic of highly heterogeneous and possibly technically composite structures. Such light behavior was previously recorded only for artificial surfaces and industrial aerosols under terrestrial conditions. Directional coincidence with the region of the WOW signal, 1977. The projection of Atlas's trajectory onto the celestial sphere indicates that its path roughly coincides with the direction from which the famous WOW radio signal was detected nearly half a century ago. Of course, one can speak of a coincidence, but the probability of such a duplication of the direction of interstellar arrival and the source of a once detected radio noise has revived debates about possible routes for intelligent messengers. Anomalous photometric evolution. The changes in Atlas's brightness do not obey conventional thermal logic. Its brightness suddenly increases, accompanied by strong green emission, and then drops sharply. These flares do not correspond to standard activity curves dependent on the distance from the Sun. Such behavior indicates either unstable chemical reactions of rare volatile substances or energy emissions of a non-thermal nature. The paradox of acceleration without visible mass ejection. The recorded non-gravitational acceleration indicates that the body is receiving momentum, as if ejecting material, yet this is not visually confirmed. There is no massive tail or extensive dust coma observed. According to calculations, to maintain such acceleration, the comet would have to lose billions of tons of matter, but this simply isn't happening. The paradox of the 5 billion tons arises. The thrust effect is present, but its source is invisible. Symmetrical ejections without recoil, a violation of the balance of forces. Even during observed fragmentations and ejections, Atlas maintains external symmetry and orientation stability. According to Newton's third law, any directed outflow of matter should cause an opposite impulse. However, with Atlas, nothing of the sort. The movement remains smooth without visible fluctuations. Such behavior can only be explained by perfectly balanced ejections in all directions, simultaneously, or by the presence of momentum compensation mechanisms, which suggests a high level of internal process organization. The totality of these 10 anomalies makes Atlas perhaps the most enigmatic interstellar object ever observed. Each individual feature could still be explained by natural deviations, but their combination is too consistent to be mere chance. Therefore, December 2025, when synchronous observations from Earth and orbital platforms are planned, will be a decisive moment. Either Atlas will confirm its unusual but natural origin, or humanity will face an object that will force a re-evaluation of the very definition of a comet. A coordinated observation campaign, scheduled from late November to January, with a key date of December 19, 2025, is set to be a litmus test for all hypotheses. Scientists intend to look for a massive coma compatible with the loss of 10% of the object's mass, clear spectroscopic signatures of CO, H2O, nickel, and exotic compounds, potential non-thermal emissions, gamma-ray, microwave signals, detailed polarization mapping to understand the nature of the particles, and ultra-precise astrometry to confirm controlled motion or variable accelerations. This comprehensive dataset will allow researchers to distinguish between the scenario of a natural, large-scale outgassing inversions involving directed or high-velocity mass loss, or even more exotic ones, including an artificial origin. The scientific community now faces a simple yet rigorous task: to collect diverse, independent datasets and compare them. Only through the synthesis of high-quality imagery, spectroscopy, polarimetry, and precision astrometry will it be possible to definitively weed out the less plausible explanations and reveal the true nature of Atlas, whether it is an exceptional natural object, the result of an unexpected internal physical process, or, in the most extreme case, an artifact that forces a radical reassessment of our understanding of what is happening in the universe,